Um, Good afternoon, everyone. First of all, thank you for coming for your presentations. I would like to congratulate the previous speakers. Thank you very much for your really interesting conference. As part of the second sessions of this event dedicated to hardware, I would like to focus in the IoT solutions for wildlife acoustic sensors. I've divided the conference into two parts. I will start with the limitations of the acoustic sensors, followed by the descriptions of the Internet of Things, its technologies, and a brief comment about the application. Then the second part is about our participation in the Transnet project.
Wait, sorry. Piccolo è
Share screen. To share screen.
I'm sorry. Can you see it now? Yes, we can. Okay, so
Okay.
sorry about that.
No
I'm
problem.
really sorry.
Quickly, two parts in the presentations. First one about the limitations of acoustic sensor and the IoT, and the second one focus on the participation of my team and the Civil Center in the Transnet project, starting with the objectives. I will continue with a study of the environment of the campus, followed by the main characteristics of our sensor and the stage of development to conclude. I think at this time, everybody more or less know what is an acoustic sensor. And like Becky has said before, their limitations. The most important one is that the recording and data processing position or ubication isn't the same. It's necessary to go into the sensor and pick or collect the SD card to reduce the number of trips as much as possible. The batteries should have large capacity. Even so, you have to go regularly because the batteries must be replaced. Finally, of course, as the offer is reduced, they have a high cost. What is the solution that we present? We propose the IoT in order to design an autonomous ecosystem monitoring unit powered by photovoltaic solar energy to record and remotely transmit continuous data streams from file sites over long periods of time. This image is from the paper that you are seeing in the screen, a really interesting paper that we are using as a reference. I encourage you to read it. And what are the IoT? The IoT, which means Internet of Things, implies the communications between nodes connected by internet or other networks. The goal is to exchange data even with devices that are far from each other. Here you have some numbers about the increase significantly that they have done in the last years. Here you have the surprising and amazing quantity of 35 billions of devices in the last year. The IoT belongs to the world of informations and communications technology. Among all of them, due to his flexibility and the opportunities they present, the wireless communications stand out. The essential requirements or specific requirement set by final applications will be divided in these three categories. The technical factors in the hardware layers that include data rate, the latency, the range, the duplex or bidirectionally, and the reliability or the loss of message. Then the complementation factors in the implementation phase. The cost is the most important one, the sum of the device and the structures, the ease of development and the status, such as the standards. And finally, functional factors in the everyday work that includes the energy consumptions, the updating, the local service, or the IP connectivity. Here we have the main LP1 communications, the acronym of Low Power Wireless Area Network. In this table, you can see the value of the characteristics that I've been showing you in the slide before. The optimal selections is based on the specific characteristic on the natural environment, the human activity, the wildlife. In our case, here from our campus and our sensor, we want to send audio files in a medium large distance and with the little energy as possible. So for us, the best option of all of this technology is the LoRaWAN communication. And some applications, there are many applications here are setting, starting with the back node. We have designed the back meters, for example, to measure the current or the power of a line, and the back sense to measure as well the present, the humidity, or the temperature, as well as the rest of devices to create a complete structure, such as the backlink. The implementations of these devices has allowed us to transform the settings into a smart building. From this point, we start with the acoustic sensors and that we are designing here and our participations in the Transnet project. The main objectives are to monitor the campus and our environment, to do an analysis about how human activities or how human beings affect the wildlife, and design an autonomous, efficient, and robust bioacoustic sensor. With the help of Luis from the Doñana Center, we carry out a study of the environment. We analyze the structures, the activity, and detect the presence of three kinds of animals: the birds, bats, and mammals. Each of them is affected by all of these aspects: the light, the noise, and the presence. Therefore, we need the appropriate sensor according to the case. We produce commercial sensor to perform this analysis. For birds, acoustic sensor that we are located both forest and pasture areas. Ultrasonic sensor, especially for bats. In the basis area, this is the blue box is the IT university, and the other one is the area where we have our smart street lightings, which intensity is completely under our control. So we could analyze the behavior of the bat and how the light affects it. Regarding mammals, rabbits stand out. This is why we located the camera traps in the grasses or pasture areas. With the information that obtained with these devices also allow us to verify the performance of our sensor. We are designing an acoustic sensor for birds. To facilitate the development of the sensor, we have divided into 4 factors: the structures, the locations, the hardware software sensor, and finally data processing. They are interrelated, so the results and the conditions affect the others. The main element is a Raspberry Pi also, and we have to the system is powered with photovoltaic solar energy, and where it's not sun, we use batteries, both of them regulated by a solar controller. The structure is protected. The devices are inside waterproof boxes or watertight bags to protect it against weather and climatic adversities and wildlife, and it has also a security system to prevent thefts. The location is the easiest point. We believe that the best solution are the open areas. On the one hand, because batteries are heavy, and in the other hand, because the leaves of the trees could shadow the panels. In addition, we are going to locate it near our smart street lighting to know if the light also affected the birds as with bats. The main elements of the sensor I already told you, but we have also a microphone to record all the sounds and an SD card to store them. The novelty of this system is that we record and set the data simultaneously. At the same time, we record, we send information from the Raspberry to the FIPI through the UART, and send information from the FIPI to the server through LoRa communication. Finally, once the recorder has been obtained, it's necessary to do a data processing. First, it's essential to filter the sound, to eliminate the noise, such as noise bars. In this case, we are using a commercial acoustic wildlife software, that is called Kaleidoscope. And then the next step is complex because it is based on the detections of a specific species. To give you an idea, we have more than 120 birds here on the campus. So we are looking for sounds and songs in the zoological acoustic libraries to compare them with our recordings and detect the species through artificial intelligence. In this point, there is an interesting question that we have 2 options for processing. If we process on the Raspberry, the amount of information sent to the server is smaller. However, if we do the data processing on the server, there is only one detecting system or software to all of them, and it's improved for the information of all the Raspberries. So the last slide to finish, I think you already know the achievements. We have analyzed the environment. We have achieved a sustainable and efficient power system with solar energy, and we are able to record. in process the deployment of our sensor and the commercial sensor in the Ukraine campus, the data processing, and improve audio setting to make it more intuitive for the users. And what we're going to do in the next month and our future goals. Study if our sensor have the same features that the commercial one, collect all the data and to do a study of how human being and activity affect the environment, and finally to get an autonomous system. That's all. Anyone have a question?
Thank you, Laura. Yeah, feel free to raise your hand or write your question in the chat. I might, if you write in the chat, I will probably ask you to open your mic. If someone also here has any question, feel free to ask it. Question or comment? So I have a question for the one of your future goals. And you said that, or no, it's in process to have the audio setting more user friendly. Maybe what are you planning to do for that?
Well, the Raspberry is programming with Python, so we are trying to reduce the capacity of this program and to do it easier. And for example, we use protoboards with LEDs that simplify the system because the users can press the button and see in a screen what they are doing or what their selections or the duration of the time that they are going to record. So you don't need to know informatic or communication to use this sensor.
And something we mentioned, I guess yesterday, is the fact that because you have the LoRa communication, you can exchange with the sensors as they are recording. Do you think you could use an app to set up the recording schedule, for example, or the audio setting?
Okay. Well, commercial sensors should have applications, so the final idea is to do enough too, because it's the same, it's like an audio setting, it facilitates the final user to employ it. So yes, the thing is that Anna, but this is like the last step of all the process, because you need to have all the system or an efficient system to come do this kind of improvement.
There is one.
One hand up. Okay, Anthony, feel free to.
Thanks. Thanks very much for the talk. I'm just wondering, like what Raspberry Pi model did you use, and was it hard to kind of think about sourcing all the pieces of hardware?
We are using a Raspberry Pi, I think. For Raspberry Pi 4. That's what we are using.
And then like the connections to that, like did you source them all from different places? Or was there kind of an easy way to, you know, source your power supply and your different sensors?
I hear it's Guillermo also from UPM. I don't get the question. You mean the connection, the power source? How do
Yeah,
you-
so I guess the solar panel and the power converter and the battery, they'd be separate. But in terms of like, was there a lot of choice in the microphones that you picked and the other, like the weather sensors and things like that, or did you have to, did you get them all from different places, or is there kind of an easy place to, if I want to connect things to my Raspberry Pi, can I, get a bunch of sensors from the same supplier?
Yeah, well, for this device, the idea is just also the idea is to use a Raspberry Pi to make the prototype also, because when it's finished or for real implementations, as someone has mentioned before, I don't think using a Raspberry Pi is the optimal choice. But of course, the idea is to use a single device, or integrating not only the audio sensor or bioacoustic sensor, but also other sensors, including ambient parameters like temperature or other weather climate sensors. Regarding the powering or the powering source, these are irrelevant in terms of power consumption compared to the power consumption by the acoustic sensor, and also by the power consumption by the communications. That are the two most significant sources. So it's not a problem.
Thank you.
Anyone has a last question before we move on to the discussion?
There is a very specific question about Charlotte Trick PhD.
I think it's
I think it was Carlos who mentioned it.
Charles.
yeah,
That's inside the discussion. Okay.